Hey guys, so I chose to do Physical World Stage 3 and I chose the freezer balloon experiment, so let's investigate. So the testable question was what happens to a balloon when we change the environment it is placed in? And the syllabus links for this are plans and conducts scientific investigations to answer testable questions and collects and summarizes data to communicate conclusions, explains how energy is transformed from one form to another, and plans and uses materials, tools, and equipment to develop solutions for a need or opportunity. So the prediction is that the balloon will shrink in the freezer. And the method, so the materials that we needed were 2 balloons, a balloon pump, some ribbon, a ruler, and a freezer. So the step 1 of the method was to using a balloon pump, use 5 pushes of air to inflate both balloons to ensure equal inflation. So this is just ensuring that the test is kept fair. If you blew it up with your mouth, could be possible to get them to the same size, but might be a little bit more difficult. So using the balloon pump ensures fairness. And then you would cut a piece of ribbon and place it around the circumference of the balloon, and then taking that ribbon off and then measuring it with a ruler just to see that they both are the same size. And this will be used later when we measure the balloons. So step 3 was to place 1 balloon into a freezer and 1 into just a neutral room or environment as a control. So for me, I just used obviously my freezer here, and then this was just placed into my living room. So just a completely neutral environment. So after 2 hours, observe both balloons and record the observations. So here were our observations and results. So after 2 hours, the control in the neutral environment balloon, that had no observable change. The balloon had neither inflated or deflated, which was pretty on par with what we were thinking. As for the freezer balloon, after 2 hours, the balloon had actually shrunk slightly. It was visible that it had shrunk, and when I took it out of the freezer, it expanded back to its normal size. So that was a really cool thing to observe. I did take a video of it, but it just wasn't very obvious in the video. But yeah, like in my hand, it did definitely expand back to its normal size. So this was a measurement table. So using the ribbon, so the measurement before for both of the balloons was 32 as expected. For the control balloon, it stayed at 32, but for the freezer balloon, it actually went down to 26. So not only can you see through visual observations that the measurements had changed, you could obviously see it through the actual measuring of the ribbon around the balloon. So the conclusion was that the balloon that was in the neutral environment showed no observable change, and the balloon that was placed in the freezer shrunk in size and then later returned to its original size once removed. As air cools down, it compresses and therefore exerts less pressure on the balloon, and when the balloon reaches a cold enough temperature in the freezer, it will visibly deflate. When the balloon is brought back to room temperature, it will return to normal. And if you heat it, so if we did a different experiment, if you heat it, it will actually get bigger as the air expands. So it's just about that kinetic energy inside the balloon and how, heat can change and impact that. So working scientifically skills. So for questioning and predicting, students were posing testable questions. So what happens if we change the environment? What happens if we put it in this room versus that room, or this freezer versus this? And making justified predictions about scientific investigation. So what they think will happen and why. As for planning and conducting, identifying, creating questions to investigate the scientific ideas, like let's explore how energy can be affected by the cold or by temperature. Plan and apply the elements of scientific investigations to answer problems. Identifying potential risks and managing resources safely. That wasn't as applicable with this particular experiment. There wasn't really any risky resources or risky materials used. But yeah, like this particular experiment didn't really have anything super risky. Decide which variable is to be changed, measured, and kept the same. So in order to create a fair and reliable test. Selecting appropriate measurement methods, so observational and formal measurements, to record data accurately and honestly. So we used the formal measurement of measuring the ribbon, and digital technologies was using the camera to take a picture of the balloon and obviously just visual. Reflect on and make suggestions to improve fairness, accuracy, and efficiency of a scientific investigation, and manage investigations effectively, individually, and in groups. For processing and analyzing, it was constructing and using a range of representations, including tables and graphs, which they did to represent and describe observations, patterns, or relationships in data. Employ appropriate technologies to represent the data. compare your data with predictions, which ours matched our prediction, and present data as evidence in developing explanations. And as for communicating, just communicating ideas, explanations, and processes using scientific representations, including multimodal forms. As for design and production, this particular dot point hit the producing and implementing design and production outcomes, and there we go. So for design and production tasks, the party store has run out of balloons, suggest another item we could use to test the same scientific concept. Or our school canteen freezer has broken down, how can we make a cold enough environment to observe a change in the balloon? Or we don't have access to ribbon, what's another material we could use to measure the circumference of the balloon? So just giving the children identifiable tasks that have needs that need to be fulfilled. So how are they going to measure it if they don't have a ribbon? How are they going to get somewhere cold enough if there's no freezer? Or what else could we use other than a balloon that could give us a similar result? So it's getting these children to really think and be innovative with their ideas. And then as for syllabus links, it's all those outcomes that I mentioned before, and then the content was just identifying different types of energy transformations. So that was about all.